Let's look at another example. Say I wanted to solve the triangle ABC, and I am told the following. A is a 35-degree angle, the side of A is 12, and the side of B is 16. So if I'm just sketching a picture, say this is my triangle, ABC. Once again, A is a 35-degree angle, side of A would be 12, and the side of B would be 16. Notice with our information, I'm giving us two sides and an angle, but notice that the angle is not being included. So side angle means that we've got this ambiguous case. So we could either have no triangle, one triangle, or two triangles. Just like all the other times, let's go ahead and let's use the law of sines to first and foremost find the only thing that we can, which would be angle B. Because I'm given the side of 12, and I know that the side across from it is the angle across from it is 35, we'll have 12 over the sine of 35 degrees. That equals the only other side we have is 16, and that's across from angle B, so 16 over the sine of angle B. When I cross multiply, we'll have 12 times the sine of B equals 16 times the sine of 35 degrees. We'll divide by 12. And once again, because we are now trying to find what the sine of angle B is, we have to use our inverse button in our calculator. And when we carefully type this in, I find out that the measure for angle B ends up being a number, so we know we'll have at least one triangle. I get 50 degrees. So we have one triangle with a 50-degree angle. We also want to determine if there will be a second triangle. So I'm going to take that 50 degrees, and what I'm going to do is, once again, I'm going to determine with the supplement what the obtuse angle would be. So if I take 180 and subtract 50 from it, I will see that I get 130 degrees. So hopefully, if you notice, going back to the original triangle, if my angle A is 35 and we got angle B to be 50, obviously those two will add up to something less than 180. And so we will be able to find our third angle of the triangle. So now that's the same thought process that I want to be thinking about with this obtuse angle. So if I add 35 and 130, I am hoping to get something that is less than 180. And notice that when I add those two numbers together, I do get something that is less than 180. So that indicates to us that we do have two triangles this time. So angle B is going to be 50, but our second triangle, we can have angle B also being 130 degrees, which means that we won't only have one angle for B, but we're actually going to have, we're going to have two angles for B, and we're also going to have two angles for C, which means that there will also be two different side lengths for C as well. So if I start with the obtuse angle of 130 degrees, we can find angle C by, once again, understanding that if that's 130 and 35 add up to 165, I'm going to subtract 165 from 180, and I see that my angle C has to be 15 degrees. If I go to my acute angle of 50 degrees, well, that and 35, I want to subtract that from 180, and that will get me the other angle C. So when I subtract 50 and 35 from 180, I get a 95-degree angle. So the last thing we have to do is calculate the side for C. So let's start with the first triangle here, where our angle B is 50 and angle C is 95. So if I want to find the side for C, I know that it's going to be over the sine of angle C, which is 95 degrees. You can go back to either one of the sides that we have. We have 16 for a side, we have 12 for a side. I'm just going to use the 12. So if I use the 12, that means that's across from angle A. Angle A is a 35-degree angle. Cross multiply, C gets multiplied by the sine of 35 degrees. That equals 12 getting multiplied by the sine of 95 degrees. I got to divide by the sine of 35 to get side C by itself. We can carefully type all of this into our calculator at once. Because we want to find our sides to the nearest tenth, I'm looking for one decimal place. That gives us a length of 20.8. Notice that because angle C was the biggest angle, it was 95, B was smaller because it was 50, A was smallest because it was 35. It makes sense that side C has to be the biggest side because it's across from the biggest angle. 16 is across from 50, which was the angle that was in the middle. 35 was the smallest angle, 12 is the smallest side. So all of that checks out with the relationship of sides and angles of a triangle. I have to go back and now do another setup to find what the other length of C is if we're dealing with that obtuse angle. So if I want to find side C, this time I am dealing with an angle that is 15 degrees. Once again, doesn't matter really what side you use that's given to us. I'm going to just stick with the 12. So that means that we have to stick with the angle that's across from it, which is 35 degrees. Cross multiply here. C is getting multiplied by the sine of 35 degrees. That equals 12 getting multiplied by the sine of 15 degrees. We'll divide by the sine of 35 degrees. Carefully typing that into our calculator and rounding to the nearest tenth, we end up with a side of 5.4. 15 degrees is the smallest angle. That makes sense then that 5.4 is the smallest side. So this gives us all of the answers to both of our triangles because side-side angle gave us that ambiguous case.